Assalamu alaikum, my dear brothers and sisters. Have you ever wondered how we can monitor vast tracts of land without setting foot on them? Take a moment and ponder this question. Imagine the vast plains of the Serengeti, the dense Amazon rainforest, or the icy tundra of Siberia. How do we collect data on these expansive, often inaccessible areas? The answer lies in a technology known as remote sensing. Remote sensing in its simplest form is the science of obtaining information about objects or areas from a distance, typically from aircraft or satellites. It's a bit like having a superpower, the ability to see without directly touching or being in the immediate vicinity of what you're examining. This technology has revolutionized the way we understand our world, enabling us to monitor environmental changes, plan urban infrastructure, manage natural resources, and even predict natural disasters before they happen. Consider, for example, a farmer in the Midwest. With remote sensing, he can monitor his crops without stepping foot on his fields. He can assess the health of his crops, check for signs of disease or pests, and even determine the best time for harvest, all from the comfort of his farmhouse. Or consider a team of scientists studying deforestation in the Amazon. Using satellite images, they can track changes in forest cover over time, identify hotspots of illegal logging and assess the impact on local wildlife, all without risking their lives in the dangerous and often inaccessible terrain. But how exactly does this technology work? At its core, remote sensing relies on the detection and measurement of radiation or energy emitted or reflected from distant objects or areas. This energy is captured by a variety of instruments and then analyzed to reveal valuable information about the objects or areas under study. The instruments used in remote sensing range from simple cameras to sophisticated satellites, each with its own unique capabilities and applications. These instruments detect different types of radiation, including visible light, infrared, and even microwaves, each revealing different aspects of the objects or areas under study. This fascinating capability is made possible through the use of various instruments and techniques, which we will delve into shortly. When you think of remote sensing, one of the first instruments that likely comes to mind is the satellite. Indeed, satellites play a pivotal role in remote sensing. Like silent sentinels, they orbit our planet, their eyes trained on the Earth's surface, capturing images that provide us with invaluable data for analysis. Imagine this: a satellite, thousands of miles above us, hurtling through space at mind-boggling speeds, all the while capturing the Earth in astonishing detail. It's a marvel of modern science and technology, a testament to human ingenuity. There are various types of satellites used in remote sensing. Some are weather satellites, constantly monitoring the Earth's atmospheric conditions. They track storms, monitor temperature and humidity, and provide us with the data that powers our weather forecasts. Without them, predicting the weather would be much like playing a game of chance. Then there are Earth observation satellites designed to study the Earth's surface. These satellites take detailed images of the Earth, allowing us to observe changes over time. They're the ones that monitor deforestation, track the melting of polar ice caps, and help us understand the impact of natural disasters. They provide us with the data that helps us protect our planet. Satellites capture these images using a variety of sensors. Some use visible light, similar to the way our eyes see the world. Others use infrared or microwave sensors, which can see through clouds, detect heat sources, or even penetrate the Earth's surface. These different types of sensors allow satellites to capture a wide range of information about the Earth's surface. But as incredible as satellites are, they're not the only tools in the remote sensing arsenal. There are other instruments, other eyes in the sky, that play just as important a role in understanding our world. Satellites, with their bird's-eye view of the world, are crucial tools in remote sensing, but they're not the only ones. While satellites hover miles above us, closer to home, we have aircraft and drones playing a vital role in remote sensing. These airborne devices have been instrumental in our understanding of the world around us, serving as our eyes in the sky when a closer look is necessary. Let's unravel this a little more. You see, aircraft and drones are often used when satellite imagery just won't cut it. They provide higher resolution images, which are often crucial for more targeted observations. For instance, in precision agriculture, Drones can capture detailed images of crop fields, helping farmers identify areas that need attention. In the realm of archaeology, aircraft can help uncover hidden structures beneath the Earth's surface, providing a new perspective on our past. The beauty of these devices lies in their versatility. They can carry a variety of sensors, including cameras, thermal sensors, and radar systems, each serving a unique purpose. Cameras capture visual images, while thermal sensors detect heat sources, useful for identifying forest fires or volcanic activity. Radar systems, on the other hand, can penetrate clouds, allowing for observations even in poor weather conditions. Moreover, drones in particular have the added advantage of being relatively inexpensive and easy to operate. This has led to a surge in their use across various sectors, from environmental monitoring to disaster management and even wildlife conservation. However, it's not just about capturing images. The data collected by these airborne devices is processed and interpreted, transforming raw information into valuable insights. This process, known as image interpretation, is a fundamental aspect of remote sensing. It enables us to understand patterns, relationships, and trends, thereby providing a deeper understanding of our world. To sum it up, while satellites provide a broader view of our planet, aircraft and drones bring us closer to the action. They offer a more detailed perspective, allowing for targeted and precise observations. Their versatility and accessibility have made them indispensable tools in the field of remote sensing. Aircraft and drones then offer a more detailed perspective compared to satellites, making them invaluable for certain types of remote sensing. Finally, let's turn our gaze to the instruments on the ground that contribute to remote sensing. While our eyes in the sky offer a grand overview, our tools on the terra firma give us an essential, detailed perspective. Consider the Hubble telescope, an instrument that has been aiding our understanding of the cosmos for centuries. But did you know that telescopes also play a pivotal role in remote sensing? They collect images of the Earth's surface in various wavelengths of light, providing a unique perspective that can reveal hidden patterns and features. Next, let's shine a light on LiDAR, or light detection and ranging. This technology uses pulses of laser light to measure distances and create detailed, three-dimensional maps of the Earth's surface. LiDAR is incredibly precise, able to detect minute variations in elevation, making it invaluable for studying topography, water depth, and vegetation structure, among other things. And then we have radar, which stands for radio detection and ranging. Unlike LiDAR, which uses light, radar employs radio waves to measure distances and map the Earth's surface. Radar has the unique ability to penetrate clouds and work in the dark, making it an all-weather day or night tool for remote sensing. All these ground-based instruments work in harmony with satellites and aircraft, each contributing its unique perspective and capabilities. They provide us with a more complete and detailed understanding of our home planet. Whether it's tracking the movement of glaciers with LiDAR, identifying geological formations with radar, or observing atmospheric phenomena with telescopes, these tools allow us to see beyond what's visible to the naked eye. Ground-based instruments then round out our remote sensing toolkit, providing a comprehensive array of data for geospatial analysis. They remind us that while we may reach for the stars, sometimes the answers we seek are right here on the ground. So, we've journeyed from the far reaches of space to the ground beneath our feet, exploring the various instruments used in remote sensing. We've seen the satellites, those vigilant eyes in the sky, capturing images of our Earth from an unparalleled vantage point. We've soared with aircraft and drones, our airborne allies that provide us with a bird's-eye view, filling in the details the satellites might miss. Then, we've delved into the realm of ground-based instruments, from telescopes that gaze at the stars to LiDAR systems that map our terrain with astonishing precision. Each instrument, each piece of technology plays a crucial role in the grand puzzle of geospatial analysis. They work together, complementing each other's strengths and compensating for their limitations. Each of these instruments, with their unique capabilities, enables us to interpret the world around us in ways that were once unthinkable. Isn't that something to marvel at? Thank you, stay tuned and subscribe to Quest.